Now let's see what it would take to go from cylindrical to spherical coordinates. Okay, we've seen what it takes to go from spherical to cylindrical, and it's not so bad. Just have to use right triangles a little bit and understand what it is you're looking at. But it's really not bad. Now going the other way is a little worse. It's not as natural. Okay, there's kind of a natural progression from spherical to cylindrical and from cylindrical to rectangular. From rectangular to cylindrical is awkward. From cylindrical to spherical is awkward. From rectangular to spherical is really awkward. So we get a little idea of the awkwardness if we go from cylindrical to spherical. Now, despite the fact that it's a little bit awkward, sometimes we need to do it, because sometimes the function that we're integrating is easily described in spherical coordinates, but not in cylindrical. So sometimes we want the limits on our integral to actually be in spherical coordinates, even though the region itself is a cylinder. Okay, well, here's your most basic region in cylindrical coordinates. Okay, r going from 0 to a, theta from 0 to 2 pi, meaning that in the r theta plane you just have a circle of radius a about the origin, and then and of course that circle doesn't restrict z, so z could be anywhere above or below that circle, but then z is restricted to go from b to c. Okay, so b is less or equal to z, less or equal to c, so we cut it off at z coordinate b, we cut it off at z coordinate c, and now we've got a nice cylinder. Okay? So we want to describe this in terms of spherical coordinates. Well, theta is one of the spherical coordinates, isn't it? Okay, so theta being a spherical coordinate, we can say that, okay, well, theta does go from 0 to 2 pi. That part is fine. Now, what are our limits on rho? Well, if we cut our cylinder, again with any plane at any of these angles theta between 0 and 2 pi, we end up with the same kind of picture that we used previously. Okay, so we have z here, we have r here. Theta is whatever it is. It's not going to enter the process here except when we do the integral. But what about rho, and what about phi? Well, it should be clear that you have points within this cylinder where phi equals 0, okay? And a point where phi equals 0, of course, would be any point on the what we would call the r-axis, okay? Or you could have theta, or phi, equals pi over 2. Okay, so that would correspond to a point on the vertical axis, the z-axis, or theta equals negative pi over 2. So theta, or phi can go anywhere from negative pi over 2 up to pi over 2, and there are plenty of points in this cylinder where you take just any of those values. So the real kicker then is going to be rho. Okay, phi is going to go from negative pi over 2 to pi over 2, but what about rho? Now it's going to turn out that our limits on rho, our distance from the origin, will depend on the angle phi. Well, they won't depend on the angle phi, but you're going to have 2 regions in terms of phi. Actually, in this case, I guess you could have 4 regions. Okay, so for phi between here and the angle of the line from the origin out to this point on the cylinder, we're going to have one set of inequalities. Okay, I'm not doing well with finding words today for some reason. Okay, one set of restrictions from here to here, and as we go, because, well, actually for any phi between the angle here and the angle here, we're restricted just by the outer rim of the cylinder, by this line in this two-dimensional representation. If phi is from here to here, we're restricted by the top of the cylinder. And if phi is between this and this, we're restricted by the bottom of the cylinder. And I didn't choose to make this cylinder nice and symmetric with respect to the r theta plane. Okay, well, so our question of the inequality for rho, rho is going to be 0. Rho equals 0 is inside the cylinder, no matter in what direction we move. But the limits in rho are going to depend on the limits on phi, or depend on just what angle phi is. So I'm going to have to take that question out and break this thing into at least 2 questions. Okay? Now I'm going to say for phi, excuse me, between this angle and this angle, rho is going to depend on the angle phi. The limit in rho is going to depend on the angle phi, but it's going to depend only on the radius of the cylinder and on phi. So I can say this. Okay, well, down here, well, let's do up here first because it's easier to see. What's phi here? Well, the sine of phi is c, which is this distance. We just do the right triangle here. The sine of phi is c divided by the radius of the cylinder, which is a. Okay, so phi is going to have to be less than or equal to the inverse sine of c over a. Okay, on this line here, phi is the inverse sine of c over a. Now on this angle down here, phi is the negative of the sine of the inverse sine of b over a. Okay, so down here, and I said negative inverse sine of b over a. I don't have to say that. I can just say the inverse sine of b over a. Okay. If b is negative, then the inverse sine of b over a is an angle less than 0. Okay, it's a negative angle. So I didn't leave myself enough room to write out the inequality, not having anticipated, not having given myself enough room to write much of anything. So let me write down the first set of restrictions on phi. Phi would have to go from, has to be greater than or equal to this, inverse sine of b over a, c over a, and I wrote, no, it's b over a, and less than or equal to the inverse sine of c over a. Now I'm going to assume here that c is greater than b, but that's obvious by the transitivity of inequality, so I don't have to really write that down. Okay, within this range of angles phi, well, we have, for any angle phi, we're going to have our rho here, and I'm going to sketch it in a different color. We can consider this triangle. Now, on this triangle, this side is the radius A. This side is the hypotenuse. This side will, of course, be the square root of rho squared minus a squared. But that isn't particularly relevant. We're not given the value of rho. The question is, how does the value of rho here depend on the value of a and the value of phi? Okay, well, it should be clear that rho times the sine of phi will equal a. So at this point, rho sine phi equals a, which means that rho equals a divided by sine phi. So rho is going to go from 0 to again, not enough room to write it out, a over the sine of phi. Hope you can read that. Rho is a over sine of phi at this point. Okay, so our inequality would be 0 less than or equal to rho less than or equal to a divided by sine phi. Okay, so one part of our integral will be theta from 0 to 2 pi, phi from the inverse sine of b over a to the inverse sine of c over a, and rho from 0 to a divided by the sine of phi. Now I don't have room to write out the rest of this, but I'm going to let you think about it. The other restrictions on phi will be, okay, for this region here, for any phi between here and here, well, phi is greater than or equal to the inverse sine of c over a, less than or equal to pi over 2. So we'll have a region for inverse sine of c over a less than or equal to rho, less than or equal to phi, less than or equal to pi over 2. I'll put it etc. there. We have to figure out what our limits in rho would be if we're in this region. And of course, in this case, our rho would not go from here to here, it would go from here to here. So we'd have a distance c on this part of our triangle and so forth. And you have to draw that out and see how that works. And then you would have a region for negative pi over 2 less than or equal to phi less than or equal to the inverse sine of b over a. And hopefully you can read that. Again, I didn't leave myself quite enough room here. And you would have to get the limits for rho down here. Again, for any point, for example, finding the limits down here, for any point down here, for any phi down here, okay, if this is your phi, then you would have rho here, and you would have b here, and you would figure out what the limits are on rho as a function of b. Okay, and you just have to look at then this triangle and a similar type of situation up here.